Hello everyone, in this video I'm going to show you how to compute a Jacobian matrix using Matlab. First, you need to know about the symbolic functions. So to declare variables in Matlab, you use the function sims. You can look it up. So we're going to declare three variables, x, y, and z, and that's how you're doing. And then we want to compute the Jacobian of a vector field. We're going to call it f. So we're going to just define our vector field as a function of x, y, and z. We can put whatever inside the functions that you want. So I'm just going to make up some random functions. You can do it your own. So now that we have our vector field, we're going to define a vector containing our variables, because that's how the function Jacobian is going to know which partial derivative it has to compute first. So if, for example, we write a vector as x, y, z, in the first column we're going to have the partial derivatives with respect to x, in the second column we're going to have the partial derivatives with respect to y, and in the third column we're going to have the partial derivative with respect to z. If, for example, you change and you write y, x, and z, in the first column you're going to have the partial derivative with respect to y, the second column with respect to x, and the third column with respect to z. Once you've done that, you're ready to compute the Jacobian. So we're going to define a matrix J. We're going to say it's equal to the Jacobian of our vector field f with respect to our variables contained in the vector v. We can just run our program, and we see that it indeed computed our Jacobian. But this is our analytic Jacobian, so it's for any point in space. Now, if you wanted to evaluate our Jacobian in a given point, let's say P, you will have to just define a vector containing the coordinates of that point. In the first entry, you will have the x coordinate because you previously defined the vector v as x, y, z. So you have to put x equals 1, y equals 2, and z equals 3. Once we've done this, we're ready to evaluate our Jacobian. We're going to just define another matrix. Let's say J, and we're going to say substitute in our matrix J, our analytic Jacobian, we're going to substitute the vector v with our point P. So we can just do this and run. And now you see that we have our Jacobian evaluated at the point P. But you can notice that you have sinus of 3 radians, and you may not know how much that is, so you don't want to calculate it by hand. That's why we have to convert our matrix small j into a double matrix, a matrix containing only numbers. So you say j equals double of j, and then you run your program again. Now it took this matrix j, and it converted it into a matrix containing only doubles. That's how you can do a Jacobian in Matlab. Thank you.